Consider, if you will, this situation. We know that the tangent of alpha is 4/3, and alpha lies somewhere between pi and 3 pi over 2. We are interested in the following values: the sine of alpha over 2, the cosine of alpha over 2, and the tangent of alpha over 2. So it's very important that when we're talking about this type of problem, we recognize that we are talking about two different angles, and their relationship is one is exactly double the size of the other. For example, alpha could be 40 degrees and alpha over 2 could be 20 degrees. So we may have some information about one of the angles, but we want actually all of the information about the other angle here. So in order to find the information about alpha over 2, we first want to think about all the information we can gather about alpha. Well, we really know quite a bit. We know the tangent of alpha is 4/3, and we know that this alpha angle is in the third quadrant between pi and 3 pi over 2. Okay, so let's start by finding sine of alpha and cosine of alpha from what we know. Well, we definitely know that if tangent of alpha is 4/3, we would have to say that x and y would have to be negative in the third quadrant, and x would be -3 while y is -4. Well, that seems pretty logical. Then what we're going to do is we're going to take and use the relationship of x squared plus y squared is equal to r squared. We know that from that relationship we can sub in this x value and this y value and find what r is. We square the -3, we square the -4, and we end up with r squared is equal to 25. That means r would be plus or minus 5, but in this context, r is always positive. So we will say r is 5. Great. Now I've got everything I need to identify the sine of alpha, which is y over r, or -4/5, and the cosine of alpha, which is x over r, or -3/5. Beautiful. Okay, so I know quite a bit now about alpha. Now I need to think about alpha over 2. Well, that gets a little tricky because I need to think to myself, well, if alpha is in the third quadrant, what do I know about alpha over 2? Well, let's take a look. Since we know that alpha is between pi and 3 pi over 2, we can take this inequality and multiply each piece of the inequality by 1/2. Okay, that will give us pi over 2 is less than alpha over 2, which is less than 3 pi over 4. This tells us that alpha over 2 is sitting in the second quadrant. This is going to allow us to make the appropriate sign choices, SIGN, for our functions. So what do we know about the second quadrant? We know that the sine in the second quadrant, SINE, is going to be positive. We know that the cosine is going to be negative, and we also know that the tangent is going to be negative. And so we are going to keep those things in mind as we progress in this solution process. Okay, let's review what we know. We know that alpha is in the third quadrant. We know that the sine of alpha is -4/5. We know that the cosine of alpha is -3/5. And we know that the tangent of alpha is 4/3. All right. We also know that alpha over 2 is in the second quadrant. We know that the sine of alpha over 2 is positive, while the cosine and the tangent are both negative. So let's go to our formulas. Start with sine of alpha over 2. We know that this is plus or minus 1 minus the cosine of alpha over 2. This is where the plus or minus comes in, right here. We know that the sine of alpha over 2 is positive. So here we will choose positive. Now we know the cosine of alpha is -3/5. So we're going to replace that -3/5 right here. Let's take a look what that looks like. Positive 1 minus -3/5 all over 2. Well, this is really 1 plus 3/5, right? And let's make a common denominator of 5/5 plus 3/5. This is going to give us 8/5 in the numerator over 2, or half of 8/5, which is going to be the square root of 4/5, which is the same as the square root of 4 divided by the square root of 5. The square root of 4 simplifies to 2, and then we can rationalize this denominator by multiplying by the square root of 5 over the square root of 5, and our final answer would be 2 square root of 5 over 5. Beautiful. Great work so far. Now let's continue and find the cosine of alpha over 2. It's going to be the same process. Let's identify the formula. Cosine of alpha over 2 is equal to plus or minus 1 plus the cosine of alpha all over 2. Again, reminder of what we determined here. Cosine of alpha over 2 is negative, so here we will select negative. We will put the negative 3/5 in here again. Cosine of alpha is negative 3/5, so we're going to put that in here. And we're going to proceed and simplify what we end up with. So we have the negative. We've got the negative 3/5 in here. Let's create a common denominator of 5 over 5. And this time we've got 5 over 5 minus 3 over 5, or 2 over 5. So I've got half of 2 over 5 under the radical. So we would have the square root of 1 over 5. And that's the same as the square root of 1 divided by the square root of 5, and that's all negative. So that's going to be 1 divided by the square root of 5. When we rationalize, will be the square root of 5 over the 5 negative. All right, so now we have 2 of our 3 pieces of the puzzle. Now let's go ahead to tangent of alpha over 2. Same idea. We have our formula, and we know that tangent of alpha over 2 in this case is going to be negative, so we will select our negative value here. We already know cosine of alpha is negative 3/5, so we're going to put that here and here. So we end up with something that looks like this. Negative 1 minus negative 3/5 over 1 plus negative 3/5. So we end up with making those common denominators of 5 over 5 again. 5 over 5 plus 3 over 5, which is 8/5. 5 over 5 minus 3/5, which is 2/5, keeping that negative in front of the radical. And then if we simplify this by multiplying both pieces by 5, we end up with negative square root of 8 over 2, otherwise known as negative square root of 4, otherwise known as negative 2. Well, that's beautiful. And so we have found all 3 pieces that we were asked to find. Now, one other thing to keep in mind is remembering that if you know the sine and the cosine of a given angle, you can find the tangent by just dividing. So if you know those 2 things, we could have taken 2 square root of 5 over 5 and divided it by negative square root of 5 over 5. We would have still ended up with that negative 2. Either way is fine, and either way is perfectly justifiable. All right, I'll see you next time.